This is day 20 of our Leetcodedaily question series, and today's question is binary search tree to greater sum tree. So in this question we are given with a binary search tree, and let me explain. A binary search tree is a type of binary tree in which every node at the which is left child of the current node is smaller than the current node, and every child which is at the right child, which is the right child of the current node, is greater. Like you can see 6 is greater than 4, 1 is smaller than 4, 0 is smaller than 4, and 2 is greater than 1, 5 is smaller than 6, and 7 is greater than 6. So for all these values, this will apply as it is also written here. The left subtree of node contains only nodes with keys less than the node's key, and the right contains the greater than its key. And both the left and subtrees must also be a binary search trees. So this specific tree is also a binary search tree. Okay, and now in this question, what is given? It is given with a root and a binary search tree. We have to convert the binary search tree into a greater tree, and greater tree is defined as we have to that every key of the original binary search tree is changed to the original key plus the sum of all keys greater than the original keys in binary search tree. So what it is done here, so let's take this 5. So for this 5, what is done, we have to change this 5 as sum of all the values which are greater than 5 in this tree and adding to the current value. So what is it? 6 plus 7, 13 plus 8, 21 plus 5 is 26. So we have to replace this 5 by 26. For this 8, there is no value greater than 8 in this tree, so we will simply write 8. For this 7, 8 is greater than 7, only one value, so we will write 7 plus 8, 15 in this part. Okay, the same operation for the whole binary tree. Okay, now let's understand the code.
Now we have to change this tree in such a way that every node of the tree is sum of every value at the node of the tree is sum of the all the values greater than tree and the value itself, which means here as there is 4. Okay, so as this is a binary search tree, all the values on the left of 4 will be less than 4, of course. So what we will do is we will change this value to 4 plus all these values which are bigger than 4. So how will it change? Will 4 plus 5 plus 6 plus 7 plus 8. So we have to push this value at this node. Okay, we have to change the value of this node as this. Also for 6, what we will do is we will change this value to sum of all the values greater than 6, which is 7 and 8, and the value itself. So this value will be changed as 6 plus 7 plus 8 and will be pushed here, okay, at the same place. For 5, what will be? For 5, all the values which are greater than 5 are 6, 7 and 8, so it will be 5 plus 6 plus 7 plus 8. All the values will be changed like this. For 7, it will be 7 plus 8. For 8, it will be 0 plus 8. We will initially take 0 as any variable and then we will do this process. And for 3, what will be the value at this point after operation? 3 plus 4 plus 5 plus 6 plus 7 plus 8. Okay, so we have to sum up all these values and push here. So for the 8, it will be 8. 7 plus 8 is 15. 15 plus 6 is 21. 21 plus 5 is 26. 26 plus 4 is 30. 30 plus 3 is 33. 33 plus 2 is 35, and here 36, and here also 36. Okay, so we have to convert this binary in this form, where this value will be replaced as 36, 36, 35, 33, and so on. So how we can do this is we can simply, as we know, there will be no greater value than this value. Okay, so what we will do is we will simply traverse from this node to the right direction, to the rightmost direction. Okay, we will traverse to the rightmost direction and change the value at this index. Okay, at this index, what the value will be changed, as there is no child of this node, so this value will be changed as 8 plus 0. Okay, but for this the current sum is 8. Okay, so current sum for all the values which are greater than 7 is 8, so this value will be changed as 15. So what can be the brute force approach? Okay, so brute force approach will be simple to traverse this whole binary tree and just check all the values which are greater than binary tree and just sum all of them and add to the current value and push to the node. So we will go to 0 and check all the values which are greater than 0 and sum all those values by in order traversal or any type of traversal, and we will just push this value here. Okay, and for 1 we will do the same, for 2 we will do the same. So for the brute force approach we will go to the n nodes and we will again check n nodes, so that if there is any value which is greater than the current value of that node. Okay, so the complexity will be O of n square. Okay, so the brute force approach complexity will be, time complexity will be O of n square. Okay, so how we can optimize this complexity? As this is a binary search tree, we know that the values which are at the left of node are smaller. Okay, so we don't need to check them, and the values which are at the right of the node are greater. Okay, or the any value which is the parent of the node is also greater. Okay, the parent of the node is greater always. Like for this one, 4 is greater, and I mean the right parent. Okay, so what we have to do, we have to simply come to the rightmost direction by the recursion or any traversal, and then we have to take the value of sum. So we will just declare a global variable sum, and what we will do is we will traverse from the right to the left, traverse from all the greater values to the smaller values. Okay, so we will traverse from the right to left and we will simply update the values by the current sum and adding current value and adding to the current sum, which was the sum of the all greater values. So what will happen, something like we will first go to 8, so the current value will be 8 and sum will be updated as 8. After that we will go to 7, so for 7, as sum is 8, so 7 will be updated as 15, it will be updated as 15, and the sum will also be updated as the current value, which is 15, which is sum of all the greatest values. As for 6, this 6, 7 plus 8 is 15, which we have to add in this 6, and we have this sum as current sum. Okay, so after the 7, as we change this value 7 to 15, we will go to 6. Okay, and we will, as we will go to 6, we will update the current value 6 to 6 plus 15, which is 21. So sum will be at 21, and this 21 will be wrote here, and after this we will go to 5. So what we are doing, we are simply going to the rightmost part. Okay, so rightmost child. After that we are printing the value of node, and after that we have to traverse the left child. As for this 4, we have to traverse this whole part. After this we have to update the value of this as 4 plus 5 plus 6 plus 7 plus 8 after these elements are processed, and after this we have to go left part. So if you assume every node as another binary tree forming a recursion pattern, what we can do is simply we will go to the right part and we will just update our sum. After that, if the node is not the node is not null, because as if we are going to the rightmost part and we reach 8. Okay, and again we move to the rightmost part, this value is null. Okay, as it's not pointing to any value, so this value is null, so we will just simply return, we will not update any value. Okay, for this left part we will also return simply, as this value is also null, we don't have any child of this node. And after that we have to update the value of sum. So like for this 6, we calculated all the values till here. Okay, so this 7 plus 8, 15, and updated to 6. So we are first doing the rightmost part, then the current node, and then the left part. After this 6 we have to process this 5. After this 4 we have to process this part. So what we are doing is we will just simply make a recursive function, like let's write the code simultaneously. Okay, what we can do is we will simply make a recursive function. We don't have to return anything, so let's make the function as void type make gst. Okay, make return type, and we will pass the node here. So tree node asterisk root. Okay, And is in this function, what we have to check? First we will check if the current node is pointing to null or not. If it is not pointing to null, then we have to do some operations. Okay, so what we will simply check, if root not equals to null. Okay, so if the current root is not equals to null, like in this case it has reached 8. How it will reach 8? Like when we start the function, it will start from here. So as the root is not null, okay, as the root is not null, so what we have to do, we have to go to the right part. Okay, so what we will write, we will just traverse to the right part, make gst root right. Now this function will be called, and then the function will be called for value 6 again. When we will go to that point again, the function, this function will be called as this function, as this value is also not null, so it will go for 7. After this it will go for 8, and at this point 8, the value is null, so it will return, it will not return anything, it will just simply return, and the value of sum will be updated at this point. Okay, so how the value will be updated is the sum plus equals to current root value. As I said, initially we will declare the globally integer sum equals to 0, and after that at every point when we are at the root, when we traverse all the right part of the root, we have to increment the sum. So sum will be updated as sum plus root of value. At this point sum was 15, and when we came to this point 6, when we traverse this whole point, so what we are doing is we are updating the value of sum as 15 plus 6, okay, 21, and we are pushing this 21 here. So how we will push this 21 here is we will simply write the current root value will be updated as the current sum, which is the new sum. Okay, and after this, you all know, we have, as we traverse the right part, we have to go and we update the value of the node. We have to also traverse for the left part, like this. For this 4, we have to traverse all this array, and after this execution, after updating the value of 4 as 30, we will traverse this part and we will update the values of these nodes. So we will simply call the function make gst root left, the left of the root, and the same function will be called again. Okay, and we can close the if part here, and after this, in the else parts, if the value of node is null, we will simply return, we don't have to do any operation, and we can close the function here. Okay, and in the main function, as of the code, the main function of the code is tree node strict bst to gst. The given function in the lead code is this tree node strict root. In this function we have to return the root. Okay, so we have to return the root of the changed array. So what we'll do is first simply call this function to change all the values. So we will call the function make gst, which is our function, and we will pass root here, and after the whole execution we will return the value of root, because the function is a type of function in which we have to return a pointer, so we will return the root. Okay, and that's all.
So let's run the code. Let's submit the code. Okay, so our code is accepted. And there is another thing I want to show, that in this question it is written here, this question is same as question 538. Okay, same, exact same as the question 538 in the lead code. So let's do that question also. So we could open question 538. So let's copy our code and paste it there. Let's copy the solution. I have copied the solution and we have to paste here, and remember the function name here is convert capital BST. So let's first erase it, and we have to write convert BST as the function name. Okay, so we have to change this convert VST. Okay, let's run the code. Let's submit this. So code is accepted here also. Thank you for watching.